Hello. In this video, we are going to learn about complex numbers. To begin, let's discuss what complex numbers are. First, not all quadratic functions are going to have real solutions. If you remember, sometimes we would state that the function had two real solutions, one real solution, or no real solutions. Well, in the case where it has one real solution or no real solution, that means imaginary numbers are involved. Imaginary numbers are defined as I equals the square root of -1. Complex numbers involve imaginary numbers, and they are some number a plus or minus another number I. So a plus bi or a minus bi. An example would be like 2 plus 3i or 1 minus 4i. A is our real part, and bi is our imaginary part. So let's begin by looking at some numbers and using our definition of imaginary numbers to simplify them. We have three numbers here. The square root of -3. So we can separate -3, why did I just write that? Into -1 times 3, right? We know that the definition of an imaginary number is the square root of -1. So now we can separate this into the square root of -1 times the square root of 3. The square root of -1 is I, and the square root of 3 is just the square root of 3. So now we know that this simplifies to I square root of 3. Let's look at the square root of -9. We can separate the square root of -9 into -1 times 9. Once again, we can separate that into the square root of -1 times the square root of 9. We know that the square root of -1 is I, but what do we know about the square root of 9? It's 3. So now our answer is 3i. Lastly, we have 4 plus the square root of -4. So to begin, we need to simplify the square root of -4. We know that simplifies to -1 times 4. And we know that the square root of -1 is I, and the square root of 4 is 2. So this is 2i. And then we have our 4. All we're going to do is bring that 4 straight down, just like that. Now in our next example, we're going to identify the portions of the complex number, 6 minus 4i. Remember, our complex numbers are defined as a plus or minus bi. So here we needed to identify a and b. 6 is a real number. It matches our a, so 6 is a. Now, -4i is our b, because the I is touching it. It's just that simple, I promise. Now, let's start getting to some more problems, some more complex problems with complex numbers. Did you like the way I used complex problems with complex numbers? Okay, so for the first one, we have 2 plus 3i plus 5 plus 8i. We are adding complex numbers. So all we have to do to add complex numbers is to add like terms. We have a 2 and a 5. That's 2 plus 5 is 7. Then we have a 3i and an 8i. 3i plus 8i is 11i. So that's our answer there. Now in part B, we have to notice that we are subtracting. So we need to take that subtraction, and we can just go ahead and distribute it just so that we don't make any mental mistakes, right? So now negative times 5 is -5, and negative times 8i is -8i. So once again, I'm going to combine my like terms. I have 2 minus 5, that's -3. Then I have 3i minus 8i, that's -5i. So now that is our answer. when we subtracted those two complex numbers. So for adding and subtracting, you would do it just like you would do it if the problem was 2 plus 3x minus 5 plus 8x. It's the same thing. The only thing you have to remember is that to distribute your negative. That's the most important part. Okay, we're going to combine the following complex numbers, but this time we are required to multiply. So a little bit more complicated, a little bit more work involved, but we can still do it because we know what the double distributive property is. 2 times 5 is 10. 2 times 8i is 16i. 3i times 5 is 15i. And 3i times 8i is 24i squared. So we have a 10. Then we can combine our 16i and our 15i. That's going to be 31i. Now, here we have an I squared. Let's think back to Algebra 2. We know that I is the square root of negative 1. And what happens if we square both of these things? We get I squared equals negative 1. So over here with the 24, I can say 24 times a negative 1. And what is a positive 24 multiplied by a negative 1? A negative 24. And 10 minus 24 is negative 14 plus 31i. And I want you to notice that my answer is still in standard form, which is a plus or minus bi. Conjugates. Sometimes we have to use conjugates to simplify a problem. If you have the complex number 3i plus 4, your conjugate is going to be 3i minus 4. So let's notice that in the 3i plus 4 we have a plus, and the conjugate we have a minus. So the only thing that's going to change is the operation. Nothing else, just the operation. So let's put this to practice. In this final example, we're going to combine the following complex numbers. We have a complex number divided by another complex number. Our complex number is 2 plus 3i divided by 5 plus 8i. To simplify this, we need to use conjugates. So I'm trying to simplify the denominator. I do not want imaginary numbers in the denominator. Okay, so what I'm going to do is I'm going to multiply by the conjugate. All right, so our denominator is 5 plus 8i. So we're going to multiply by 5, 8i. But what are we going to change about it? We're going to change our addition sign to a subtraction sign, right? We're only going to change the operation. So let's go ahead and put parentheses around all of this. And now we're going to distribute. 2 plus 5 is 10. 2 minus 8i is negative 16i. 3i times 5 is 15i. 3i times negative 8i is negative 24i squared. Okay, on the bottom we have 5 times 5 is 25. 5 times negative 8i is negative 40i. Positive 8 times 5, positive 8i times 5 is a positive 40i. And positive 8i times negative 8i is a negative 64i squared. So in the numerator, we see that we have a negative 16i plus 15i. That is going to simplify to a negative 1i, or negative I, right? We know that our I squared equals a negative 1. So we have negative 24 times negative 1. In our denominator, we have negative 40i plus 40i. What happens to those? they equal 0, right? And then we know that our I squared becomes -1. So now we have 25 minus 64 times -1. In the numerator, 10 minus I, and then a -24 times the -1 is a positive 24. And then in the denominator, we have 25 plus 64. Okay, so in the numerator, the only like terms that we have left are 10 and 24, which simplifies to 34, minus I, all over. In the numerator, 25 plus 64 simplifies to 89. So now if we notice in our denominator, we no longer have any imaginary numbers, and that was the goal. So now we have officially divided 2 plus 3i by 5 plus 8i. And that concludes this video on complex numbers. In our next video, we will be graphing complex numbers. So get excited about that.